Ohm's law states that the current through the conductor between 2 points is directly proportional to the voltage across the 2 points. Introducing the constant of proportionality, the resistance, one arrives at the usual mathematical equation that describes this relationship. Current equals voltage over resistance, where I is the current through the conductor in units of amperes, V is the voltage measured across the conductor in units of volts, and R is the resistance of the conductor in units of ohms. More specifically, Ohm's law states that the R in this relation is constant, independent of the current. Ohm's law is an empirical relation which accurately describes the conductivity of the vast majority of electrically conductive materials over many orders of magnitude of current. However, some materials do not obey Ohm's law. These are called non-ohmic. The law was named after the German physicist Georg Ohm, who, in a treatise published in 1827, described measurements of applied voltage and current through simple electrical circuits containing various lengths of wire. Ohm explained his experimental results by a slightly more complex equation than the modern form above. In physics, the term Ohm's law is also used to refer to various generalizations of the law, for example the vector form of the law used in electromagnetics and material science. Ohm's law states that the voltage V, across the conductor of resistance R, is proportional to the current I, passing through the resistor. See circuit below. The relationship is written as V equals R multiplied by I, which can also be written as I equals V over R, and R equals V over I. The units are in volts V for the voltage V, amperes say for the current I, and ohms omega for the resistance R. Use Ohm's law to solve simple circuits problems. Example 1. Find the current I through a resistor of resistance R equals 2 ohms if the voltage across the resistor is 6 volts. Solution to example 1. Substitute R by 2 and V by 6 in Ohm's law. V equals R multiplied by I. 6 equals 2I. Solve for I equals 6 over 2 or equals 3 amperes. Example 2. In the circuit below, resistors R1 and R2 are in series and have resistances of 5 ohms and 10 ohms respectively. The voltage across resistor R1 is equal to 4 volts. Find the current passing through resistor R2 and the voltage across the same resistor. Solution to example 2. We use Ohm's law. V equals RI to find the current I1 passing through R1. 4 equals 5I1. Solve for I1. I1 equals 4 over 5 equals 0.8 amperes. The two resistors are in series and therefore the same current passes through them. Hence the current I2 through R2 is equal to 0.8 amperes. We now use Ohm's law to find the voltage V2 across resistor R2. V2 equals R2 times I. 2 equals 10 times 0.8 equals 8 volts. Try to solve the problems given below to test your skills. Problem 1. A motor with an operating resistance of 32 ohms is connected to a voltage source. The current in the circuit is 1.5 amps. What is the voltage of the source? Answer: 48 volts. Problem 2. Determine the amount of current going through a 50 ohms resistor with a voltage of 120 volts. Answer: 2.4 amps. Problem 3. A relay with 100 ohms resistance requires 50 milliamps for operation. When connected to a 4 volts source, what will happen to the relay? Post your answer for problem number 3. Thanks for watching.